15. Prove algebraically that the difference between the squares of any two consecutive integers is always an odd number. So, two consecutive integers just means two consecutive whole numbers. But we can't just choose whole numbers. Yet it says prove algebraically. So let's call one of my whole numbers n. Right? So the next number on from that will be n plus 1. So, prove algebraically the difference between the squares of any two consecutive integers is always an odd number. So, n would be n squared, and then I'd have to do n plus 1 squared. So, n plus 1 times by n plus 1. So, n times n is going to be n squared, n times 1 is going to be plus 1n, 1 times n is going to be plus another n, and then 1 times 1 is going to be plus 1. So if I tidy this piece up, this is going to be n squared plus 2n plus 1. So the question says, prove algebraically that the difference between the squares of any two consecutive integers is always an odd number. So the difference is going to be n squared plus 2n plus 1, so this number, take away by n squared, which means these two would cancel each other out. So that leaves me with 2n plus 1. Okay? 2n must be even, so 2n plus 1 must be odd. So that would be my final for that one there. So, two questions for you to press pause and have a little go at. Pause. So, prove using algebra that the sum of two consecutive whole numbers is always an odd number. So, if I take n as my first number, and then two consecutive whole numbers, so the next one must be n plus 1. So, prove using algebra that the sum, this means the two numbers added together, must always be an odd number. So, n plus 1 is going to equal 2n plus 1. So 2n must be even, because it's a multiple of 2. So 2n plus 1 must be odd. If we look at the third and final one, prove algebraically the difference between the square of any two consecutive integers is equal to the sum of these two integers. So prove algebraically the difference between the squares of any two consecutive integers is equal to the sum of these two integers. So if we go back, we've got the n, and we've got our n plus 1. So it's a combination of the last two questions. So this squared would be n squared, this squared would be n plus 1 multiplied by that n plus 1. So going through that gives n squared plus 2n plus the 1. So the difference between these, n squared plus 2n plus 1 minus the n squared, those two cancel each other out, leaves me with just the 2n plus 1, and the sum of these two, n plus 1, also equals 2n plus 1. Remember, we don't know what the value of n is, but these two values must be the same.